All right, first thing we need is your the date on your notes here. So today is Wednesday, September 30th. And today we're doing section 2.8. And before we get into the proofs, there are a few postulates and theorems we're going to go through. Things you've already put on the cheat sheet, but we're going to show you where some of these things are coming from here. So the first one is the angle addition postulate. And I'm not going to write out all the words to this because you have that for you on the cheat sheet. What I'm going to do is give you a picture to kind of show you the angle addition postulate. So for our picture, I'm going to make a big angle. This big angle I'm going to call angle ABC. And then through angle ABC, I'm going to have a ray coming through here, splitting it into two different angles. I'm going to call those angles 1 and 2. And the angle addition postulate is going to kind of remind you of segment addition postulate. When we did the segment addition postulate, we said if you had the two little segments together, you get the big segment. Same thing's going to happen with angle addition postulate. It says if we add the two little angles together, we're going to get the big angle. So angle addition postulate here would say, if I take the measure of angle 1, and I add the measure of angle 2 to it, we're going to get the measure of the big angle, angle ABC. So if you add the two little angles together, 1 and 2, you'll get the big angle, angle ABC. And there's a couple different ways to show you how this is going to work, like when we give it to you on homework problem. So let me show you one of these. We'll call this one letter A. They're going to tell us to find X. And on this one, our picture, we have a big angle. Let's call it, we're going to call this XYZ. Actually, I don't want to find X. I want to find the measure of angle XYZ. And then inside this angle, we're going to split it up into two little angles. I have a 35-degree angle here and a 20-degree angle here. And it's really pretty straightforward when they just give you numbers like this. When they give you numbers, it's really just a matter of doing the addition on this one. We said angle addition postulate, if you add the two little angles together, you'll get the big angle, X, Y, Z. Well, if you add 35 and 20 together, that's going to give you 55. So the measure of angle XYZ, the big angle, is going to be 55. Now, we'll show you some examples with algebra in it here in a second, but for now, that's as far as we need to go there. So that's angle addition postulate. And then there's two other theorems I want to show you that were on your cheat sheet. And then we'll show you some examples with algebra in it. So before we do that, we've got supplement theorem first. And I'm going to abbreviate theorem THM. You'll see that sometimes as we go through the chapter. And once again, I'm going to do a supplement theorem with a picture instead of writing out all the words. If you see the word supplement, you'll think of supplementary. Supplementary means they add up to 180. Two angles that add up to 180. And what's going to happen here is we're going to have a linear pair. And this is kind of going to be a combination of supplementary and the angle addition postulate. We have two angles here. Angles 1, let's call them angles 3 and 4 this time. We have two angles, 3 and 4. they're right next to each other, and they form a straight line, which makes them a linear pair. And we talked about this when we defined a linear pair. A linear pair is always going to add up to 180, and that's what the supplement theorem here is saying. It says if you have two angles that form a straight line, then those two angles will add up to 180. And that's something that they will expect you, like when you see the picture of it, they'll expect you to automatically know that that's happening here. Anytime you have two angles that are right next to each other and they form a straight line, those two angles will add up to 180. So they don't have to tell you in the directions that they add up to 180. That's just something you can know by looking at the picture. Now we said supplementary add up to 180. The next one is the complement theorem. So hopefully we remember our definitions here. If supplementary add up to 180, what did complementary add up to? Complementary add up to 90. So now, instead of making a straight line, we're going to make a 90-degree angle. So we have a big angle. It's going to be split into two. We'll call them angles 5 and 6 this time. And these two are going to form a right angle, so I'm going to put the box in the corner to show we have a right angle. And then these two, if we add 5 and 6 together, oops, I need to have it in front of there. Measure of angle 5 plus measure of angle 6 will add up to 90. So there's your supplement theorem and your complement theorem. If they form a straight line, they add up to 180. If they form a right angle, they add up to 90. And then, like I said, we're going to show you some examples of how we use this with a little bit of algebra involved in there. So let me draw up an example of this. We'll call this letter B. And on this one, let's draw the picture first. We're going to have these two angles here. Let's call those angles 1 and 2. And then they're going to, in our directions, tell us a couple of things here. They're going to tell us the measure of angle 1 is 3x plus 32. They're going to tell us the measure of angle 2 is 5x plus 12. And they're going to have us 5x. And with this, like I said, it's really just a matter of identifying what's going on in your picture. When you look at this picture, hopefully you identify right away that angles 1 and 2, they're right next to each other, and they form this straight line right here. And anytime they form a straight line, that's going to be a 180-degree angle. So if we add these two together, angle 1 is 3x plus 32, angle 2 is 5x plus 12. If we add those two angles together, we'll get 180. So our equation will be just 3x plus 32 plus 5x plus 12. That's your two angles right next to each other. They add up to give you a straight line, which is 180. So we make that equal 180. And once you get to this point, now it's just a matter of collecting like terms. 3x and 5x add up to 8x. 32 plus 12 is 44. Then if we subtract 44 from both sides, that leaves us 8x on the left and 136 on the right. And then finished off, we'll divide by 8. That's going to go in there once. 56 divided by 8 is 7, so 17 times. And they wanted us to find x, so that's all the further we have to go. X is going to be 17. So there's the angle addition postulate with a little bit of algebra in there. And once again, if you look at the picture and you see they form a straight line, they're going to add up to 180. If you see in the picture that they form a right angle, then the two angles will add up to 90. All right, that's really all there is to that. Does anybody need to see another example like this, or one with a 90-degree angle? Anybody need to see that? Good with those? Okay. Last thing we have is, before I do the proof, we're going to do theorem here, vertical angles theorem. This theorem is the one you're probably going to end up using the most this year. And it's something we've already talked about this year, vertical angles theorem. And once again, I'm going to do this one with just a picture, because we've already talked about the wording for this one. Vertical angles are when you have two straight lines that intersect with each other. And it's going to form four angles when they intersect. And back in chapter 1, when we talked about vertical angles, we said vertical angles are going to be across from each other. So if you look, angles 1 and 3 are across from each other, they'd be vertical angles. And 2 and 4 are across from each other, they would be vertical angles. And one of the things we mentioned back when we talked about vertical angles in chapter 1 is we said vertical angles are always congruent to each other. And that's what the vertical angles theorem here is going to say. Anytime you see vertical angles in your picture, like 1 and 3, they're automatically going to be congruent to each other. So you can just go right to it. 1 and 3 are congruent. 2 and 4 would be congruent. Once again, this is something they don't need to tell you in the directions. As soon as you see the picture that you have vertical angles, right away you know they're congruent. And that works anytime we have vertical angles. And then I told you we were going to get into proofs here in section 8, into the geometry proofs. And our first one is the proof of the vertical angles theorem. And this proof is going to be on your test. It's going to be pretty much this exact same proof, except we're going to change the letters, we're going to change the picture, maybe change the numbers on it. But other than that, it's going to be the same proof. So here's how it works. Now, again, with your proofs, they're always going to start by giving you something, or given on this one. That angles 6 and 8 are vertical angles. And we're trying to prove the vertical angles theorem. The vertical angles theorem says if they're vertical angles, then they're congruent to each other. So we're going to prove that 6 and 8 are congruent to each other. And then with geometry proofs, they're going to give you a picture to go with it. So our picture is going to look like this. We have our two lines intersecting. We got angles 5, 6, 7, and 8 up there. And then like we did with the algebra proofs, we're going to do a 2-column proof. And in our 2-column proof, our statements go on the left and our reasons go on the right. And once again here in chapter 2, when you get to the chapter 2 test, we're going to do this as a fill in the blank. We're going to give you some of the statements and reasons. You're going to fill in the ones that are missing. So for this theorem here, I'm going to give you all of the statements. We're going to see if you guys can come up with the reasons. So here's our first statement. Angle 6 and angle 8 are vertical angles. We're going to fill in the reason for that. And then step B is going to have 2 parts to it. Step B, angles 5 and 6 are a linear pair, and 5 and 8 are a linear pair. Both of those go with step B. And our reason for both of those statements is going to be the same reason, which we'll put here under our reasons for letter B. Step C is also going to have 2 parts to it. And again, the reason for those two will be the same thing here. We'll put in steps or into letter C for the reason there. All right, that's it for our 2 steps. Now we just got 1 step for each one of these. Step B says measure of angle 5 plus measure of angle 6 equals measure of angle 5 plus measure of angle 8. And we're just about there. And our last step. Last step is angle 6 is congruent. I'll give you a second to get that copied down, and then we'll go into this one. You may need more time to copy that down. All right, since this is our first geometry proof together, I'm just going to take you through the steps and let you know where these are coming from. And then as we do more of these together later on, we'll let you guys chime in and figure out where these steps are coming from. So we're going to start with the first thing, and just like our algebra proofs we did earlier, with the algebra proofs, your first step is almost always going to match up with your given. And that happens here. 6 and 8 are vertical angles. That's what we have for step A. So our reasons here. So no matter how difficult the proof is, you should always be able to get that first step. It's almost always going to be. Now in step B, they tell us that 5 and 6 are a linear pair and 5 and 8 are a linear pair. Let's start with the first one here. 5 and 6 are a linear pair. If you look at your picture, 5 and 6 are right next to each other and they form this straight line. That makes them a linear pair. And then you can say the same thing for 5 and 8. They're right next to each other and they make this straight line, which makes them a linear pair. And if you go back to when we defined a linear pair, we said a linear pair can be 2 adjacent angles right next to each other, they form a straight line. So this thing right here is coming from the definition of a linear pair. Oh, I spelled it wrong. Definition of a linear pair. So as you're filling in these reasons, they're either going to be definitions, they're going to be postulates, theorems, properties. Basically, all of those things we have on your yellow cheat sheet. Those are going to be what we're going to fill in as reasons. Now, from step B to step C, we're going to do something we talked about in our notes here today. Step B, we said 5 and 6 are a linear pair. And then same thing with 5 and 8, they're a linear pair. So now in step C, we can say that they add up to 180. If they're a linear pair, then they add up to 180. And this goes back to, show you here in our notes, when we did the supplement theorem. Supplement theorem, we said if they form a linear pair like this, then they're going to add up to 180. That's what's happening here. We're saying they're a linear pair in step B. In step C, we're saying they add up to 180. So this right here is the supplement. So anytime you see them go from saying they're a linear pair to they add up to 180, the reason for that is the supplement. Now, from step C to step D, in step C, we've got 2 separate equations. In step D, we make it 1 equation. Here's what's happening in step D. We have both, angles 5 and 6 equal to 180, and we have angles 5 and 8 equal to 180. They're both equal to 180, which is going to make and turn them equal to each other. We're going to call this the substitution property. Here's one way to look at this. Since angle 5 plus angle 8 equals 180, what I can do is I can substitute angle 5 plus angle 8 in for 180 up here. If I do that, the 5 plus 6 is still on the left. But on the right, instead of 180, I'm going to have 5 plus 8. So that is substitution property. Anytime you take out one thing, substitute something in for it, that's our substitution property. And you'll see that a lot in our geometry proofs. So if two things are equal to each other, they're going to end up becoming equal. Or if two things are equal to the same thing, they're going to end up becoming equal to each other. Now, from step B to step E, you might be able to see this. In step B, we had angle 5 plus angle 6 on the left. Down here, it's just angle 6. Over here, we had angle 5 plus angle 8. Now, over down here, it's just angle 8. So we got rid of angle 5 from both sides of the equation. We did that by subtracting angle 5 from both sides. When you subtract angle 5, you're left with angle 6 equals angle 8. We have right here. Subtraction property allows us to subtract angle 5 from both sides. And then our last step, this one's going to happen a lot also. This one's on your cheat sheet. We're going to go from the measure of angle 6 equals the measure of angle 8 to angle 6 being congruent to angle 8. Anytime we just flip back and forth between congruent and equals, we call that the definition of congruence. And that's oftentimes our last step in the proof. So anytime you see them flipping back and forth between congruent and equals, we call that the definition of congruence. All right, so there's our first proof. And the thing with proofs is, a lot of times it takes a while to kind of figure these out. So if the first one didn't make a whole lot of sense, just give it time. We're going to go through a bunch more of these here and help you get this figured out. Okay, that is our notes for section